Kia ora Year 12 and 13. This is the first part of a YouTube video that's going to go through the exemplar for Conics on building a cover for the swimming pool. So I've put some excerpts in from Moodle just so you can see what's going on. Basically, you're given two different models for two designs, A and B. In this one, I'm just going to look at design A, which is the parabola one. You're asked to check whether the designs meet some specifications, and then you have to fix up the model so that they do meet all the specifications. Okay, and we're told that if we have to put a wall into our swimming pool cover, it has to be as low as possible. So here are the specifications that the swimming pool cover has to meet. So you need to read through these quite carefully because you're going to have to put this information onto your graph. So the swimming pool is 10 metres wide and it's got a path around it. There are changing rooms, and the cover has to be at least 5 metres above any point on the water in the pool. Okay, the changing rooms have to be 2.5 metres high to fit people inside, and the cover can't be more than 8 metres high. And the maximum width is 22 metres. So this is the model that you're given. Let's just take a look at that. So it's got a parabolic cross section, and its height, maximum height, is 6 metres, and the focus of the parabola is 1 metre above the centre of the pool. Okay, this information about the focus is crucial because if you watched the parabolas video, you'll remember that all we need to figure out the equation of a parabola is the focal length. So in here, here's my focus, and here's my vertex. So that focal length is 5 metres, and that's all we need to start modelling this situation. So we've got a vertex at 0, 6. The form of the parabola, well, it's an x squared equals 1, and it's an upside down one. So it's x squared equals negative 4a, and it's been transformed up 6 units, so it's going to be y take away 6. Now this a is the focal length, which is 5, right? So that comes from 6 take away 1. So here's my vertex, here's my focus, right? Focal length is that distance there, and that goes in to be my a. So that means my equation is actually really easy to find. It's x squared equals negative 20 times y minus 6. Now we can rewrite that in our normal form, and we'll get this. X squared equals negative 20 y plus 120. Right, so x squared minus 120 equals negative 20y, and that gives us y is equal to 6 minus 1/20 x squared. So you're probably going to be happier working in this form when we've got one that is either like this or like this. Right, so we're back to doing basically some Year 12 maths now. We have found the equation of the parabola. So the next thing we have to do is we have to write down the conditions and check that they're met. Okay, so this is a GeoGebra map of the function, right? So this is my function y is equal to 6 minus x squared on 20. Alright, the first condition is that the cover needs to be at least 5 metres above any point on the pool. So from our earlier picture, we can see where the pool goes. Well, the pool is 10 metres wide, so the pool goes from x equals negative 5 to 5. So what I've got to check is what's the height when x equals 5. And by symmetry it'll be the same for x equals negative 5. So when x equals 5, y is equal to 6 minus 5 squared, 25 on 20. So let's have a look at how tall that is. Well, that works out to be 4.75 metres. Okay, so that's less than 5 metres. So the height of the pool cover is less than 5 metres at the edge of the pool. So it's too low. So we're going to have to fix that up. Right, that's the first condition. And similarly here. So that's 4.75. Right, now the next thing we have to look at is the changing rooms. So we have to go back to our first graph and see where our changing rooms were. Well, we've got a path here right next to the pool. So there's the path. I'll put P for path. And the changing rooms then go for 3 metres. So they go all the way out from 7 to 10 metres. So what we have to check is that they need to be at least 2.5 metres high. So we're going to check the worst part of the changing rooms, which is the outer wall, and we're going to have a look at what the height is there. I'll do that on a new slide. So I'll just put CR for changing rooms. So at the lowest point of the changing rooms, we're going to have x equals 10. We'll have negative 10 on the other side, but don't worry about that. And we get y equals 6 minus 10 squared over 20. So that's equal to 6 minus 100 over 20, which is 5. So y is equal to 1 metre. Right, and that's too short. That's less than 2.5 metres high. The last thing we have to check is the width of the pool cover. And you can see on the GeoGebra that we're going to be pretty close to our limit. The maximum width is 22 metres. So how can we check that exactly? Well, we've got y equals 6 minus x squared on 20. So when will the height be 0? Checking for the x-intercepts. 0 equals 6 minus x squared on 20. That gives us the condition that x squared is equal to 120. Right, and x is equal to, that works out to be what? Let's see, I think it's 10 point something. Yep, so 10.95445. So this condition is satisfied. So this is okay. Now I'm doing this with my finger today instead of with a stylus. If I were using a stylus, I would be writing some much better sentences than this. Okay, so this is okay, it's not really very good. We need to say the pool is 21.9 metres wide. Sorry, the pool cover is 21.9 metres wide, which is less than 22 metres. So now we have to go back and we have to fix the whole thing up. And we're going to do that by lifting up the roof. Okay, so we're told that the cover can't be more than 8 metres high. At the moment it's only 6 metres high. So we're going to find a new parabola and we're going to shift it up to having a vertex at 8. Okay, so my new one is going to start at 8 and it's going to go like this. And we know that we had trouble with the changing rooms, so what we're going to do is we're going to say, we've got 0 here, my outer wall of my changing rooms is at 10, and I want my parabola to just hit 2.5 metres here, and that's going to let me get a scale factor. Right, so that means I can write my parabola now as y is equal to 8 minus k x squared. And we want to have the point 10, 2.5 on the curve. So we substitute in, we get 2.5 is equal to 8 minus k times 100. Right, onto a new slide. So 2.5 plus 100k is equal to 8. 100k, doing this very slowly, is equal to 5.5. K is equal to 0.055. So my equation is y is equal to 8 minus 0.055 x squared. In other words, it's going to be a parabola with 8 and it's going to have quite a wide scale factor. Now, while we're on this, we might as well get round to checking, if we just let that parabola go all the way out, where are the x-intercepts? So solving for 0 equals 8 minus 0.055 x squared. that will give me, let's see, let's just have a wee look at this. So that gives me x squared is equal to 8 over 0.055, which is 145.4545. Okay. If you use fractions, you'll get an exact answer on that. So that gives me x is equal to plus or minus 12.06. So that tells me that I am going to have to use a wall as part of this design because the pool can't be that wide. So at negative 11 and 11, I'm going to have to stick a wall in. Okay, and we'll keep that as low as possible. So we will be needing a wall. We will be truncating the edges of that because otherwise it's going to be too wide. So now we've got the changing rooms are sorted out. We've made it so that they are going to be high enough with the new parabola. We just have to check the third condition, which is that the cover has to be at least 5 metres above any point on the water in the pool. So the pool runs from negative 5 to 5. So now we're going to go up with our new equation and we're going to substitute in x equals 5. I'll do that on the next slide. Right, so we've got y is equal to 8 minus 0.055x squared. Sub in x equals 5 or x equals negative 5. We get y is equal to 8 minus 0.055 times 25. And that works out to be 6.625 metres. Now that's taller than 5 metres, so that condition's satisfied. So we've done the changing room one, and now we've done the distance above the water. And the last thing we're going to have to do is we should really say how tall that wall will be. Okay, and so we're going to look at x equals 11, where will the parabola be sitting? So last wee bit of substitution. Y is going to equal 8 minus 0.055 times 11 squared, which is 121. Okay, so that means that y works out to be 1.345. So the wall has to be built at 11 metres on either side, and the wall must have a height of 1.345 metres. So I'm going to sum that up on the last slide. Okay, so my vertex is up here at 8. Here comes my parabola. At these points here, we're going to have a wall, and it's going to be 1.345 metres tall. The equation of the parabola will be y equals 8 minus 0.055 x squared. At 10 metres, the height of the roof cover, of the pool cover, will be exactly 2.5 metres. So there are my changing rooms there. Okay, so that's all fine, and here's my pool. There's the path, and here comes the pool in here. Right, and that's at 5 and negative 5. And the height, the lowest height it's going to get to above the pool will be a respectable 6.625 metres, which is higher than it needs to be at 5 metres. Alright, in the next video I'm going to look at the elliptical conic section for the second design for the swimming pool cover. Thanks for watching.